So I'm Agnieszka and I'm Cloud Development Engineer at Pega. So before we start, a few words about me. So I mostly work with AWS and Kubernetes, and I hate on calls. I truly cannot rest on them, they're not for me. And I like to destroy things, not only on purpose. So before we start talking how to tame chaos, could you please tell me, are you familiar with chaos engineering? Yeah, okay, good to hear that. And did you have any chance to use it in a real-life scenarios? Yeah, okay, that's actually quite many of you. So, to start the talk, we need to know more about chaos. And my personal definition of chaos is my cat. He's running around the apartment at 3 a.m., licking the floor everywhere and sneezing whenever he can. So he is like a chaos, a state of total confusion and lack of order. And as human beings, we crave certainty. So to tame chaos, we decided to do some research. And there are actually two pioneers in that field. It was Henry Poincaré and Edward Lorenz. But we'll only talk about Lorenz today. So, American meteorologist created a simulation of Earth's atmosphere, and he wanted to predict some aspects of climate change. He let computer do its work and went to grab some coffee. When he returned, he was astonished. He digited the exact same numbers. The prediction, though, were completely two different scenarios. How could this happen? Lorenz initially thought that the computer was broken. Then he realized that the computer worked with 6 decimals, whereas he used numbers rounded to 3 decimals. So yes, a fraction of a fraction can produce a huge difference. In 1972, he organized a conference to show his works and findings. And on the very same conference, he introduced a widely known effect, the butterfly effect. So effect simply states that if there is a butterfly somewhere and it flaps its wings, then it will cause a tornado somewhere else. And fun fact, originally, Lorenz wanted to call this effect the seagull effect, but to make it more poetic and romantic, he sticked with a butterfly. And yeah, those tiny changes can make a massive impact. That's not hypothetical. That's the law. And that's the chaos theory, the study of apparently random or unpredictable behavior in the system governed by deterministic law. But why are we talking about chaos theory in chaos engineering? So, distributed systems used in IT are complex ones, which implies they're chaotic. Because changing operating conditions in one system can change operating conditions in others. But it's not only technical side, but also people side. So imagine that you were on a great conference, like this one, on Thursday, and you met some new people, then in the evening you decided that you want to grab a beer. I assume that you didn't get a proper sleep that night, right? Then, on Friday, you do some changes, you push it on the production, and many things can happen, right? That's why we have chaos engineering, which is the discipline of experimenting on distributed systems to build confidence in the system's capabilities to withstand turbulent conditions in production. And actually, chaos engineering is quite a new thing. In 2008, Netflix, who's quite a young company at the time, suffered from well-known and extremely tough outage. They were down for 3 days. That was the moment they decided we want to go to the cloud. We want to use AWS. And they started the transition. That was the moment that chaos engineering was born at Netflix. And probably there were some other companies that did this before, but it was never formalized. So what did they do? They started to change people's mentality and created a simple tool called Chaos Monkey. So what this tool was doing, you can think of it as you have a monkey. You give it a gun. Then you put it into the server room, and it starts randomly killing your servers. And that's exactly what this tool was doing. And it was pretty successful. So they decided to move on and create some other tools, like Chaos Gorilla, eventually creating Netflix Simian Army, which is a tool to test security, resiliency, and reliability of its Amazon Web Services. And they put those tools on GitHub around 2011. In 2014, first person was hired to the role of Chaos Engineer at Netflix. And the first Chaos conference was organized in 2018. Why are we talking about it here? So, founders of Gremlin, which is also called Failure as a Service, organized this conference. And they worked at Netflix at the same time that Chaos Engineering was born. So they know its fundamentals and everything inside out. That's why they also created a Gremlin like 2 years before. And over the time, more and more companies started to introducing chaos engineering into their systems based on the great success of Netflix. Knowing all of that, we will move to principles. So about the building hypothesis around the steady state behavior, we'll talk a little bit later. But overall, you want to be as close to the real world as possible. So as close to the production environment as possible. But let's face reality. If you start on production, you will most probably fail. So start with a test or even development environment and slowly move to production. And automate those experiments. Think of them as some kind of a deployment process or quality gateway that your code is verified against. And start slowly. Be agile. You don't want your system to explode, right? There are actually few questions that you need to ask yourselves before implementing chaos engineering. The first one is your service ready for the real world? So this means that most of the bugs are fixed, there is workaround for remaining issues, and overall system is working steadily. If this is not the case for you, do the needful. Fix the system. Then check if you have monitoring in the steady state. Why? To see how system is behaving under the typical load and do some conclusions. We can describe our system with a set of parameters like CPU usage, memory usage, latency, pod availability, and many more. And by that, we know if our system is healthy or not. Then, if monitoring is in place and people working on the system are confident in its resiliency, then it's the best time to start chaos engineering in your company. And here, I wanted to show you chaos engineering form, which is actually used by Target, an American company, in their organizations. And we'll smoothly go through it and explain all the parameters. So first, you need to choose the application on which you want to perform your tests. In here, this is the proxy service. Then you choose the attack type. It can be somewhere like on CPU, on memory, on network. In here, they decided to check how system will behave under the slower networks. Then the duration. It can be anywhere from few seconds to few hours, even few days. The scope of attack. It can be entire cluster, single instance, several instances in the same region, different region. It's up to you. Environment. So as I said before, I would start on non-production environment, and that's exactly what Targets did. And load. It can be it's actually data used in the experiment, so it can be synthetic, simulated, or actual user data. Here, we are bombarding our system with 20,000 queries per second to see how it behaves under that load if it will be able to handle the real-world scenarios. Then you can also set some kind of an abort condition. So when to stop the experiment. For example, it can be when business operations are disrupted or actual users cannot connect to the application. Then the observability. And this is a must-have for each chaos engineering experiment. Because you need to know if your system is healthy or not, if it's responding. This is a totally must-have. And you can either use things like Grafana, New Relic, or some other solution of your choice. Then you create a hypothesis, which states possible failures and impacts. In here, you want to just check if threshold of the metric is properly set. Then the results, which are outcomes of the experiments. And here our experiment failed because no alerts were triggered. And action items are as important as other things in our experiments because they state some kind of a follow-up task, like fixing telemetry, resolving bugs, and, for example, changing conditions of the experiment. It is also worth to create some kind of a backlog item for them, just not to forget about them. And as we all know, what parameters are needed, we can use some tools that are widely available at the market. And actually, there are over 50 tools for chaos engineering that proactively test, intentionally introducing failures and so on. And I prepared a table with 5 of those tools, and we'll evaluate them by spectrum of parameters like design principles, key features, scalability, performance, ease of implementation, and its limitations. And each tool is unique and has different use cases, and I will go smoothly by each of them. So Chaos Monkey works well for companies that use Spinnaker and want a simple way to test their systems by terminating the single instances. Gremlin, on the other hand, offers a wide variety of attacks, simulations, and strong platforms, making it great for companies that want reliability testing with detailed insights. Litmus Chaos is actually a open source tool perfect for Kubernetes setups with large collection of experiments. Simorg is flexible, can be easily customized, perfect for companies who want script-based solutions. And SteadyBit offers detailed control over the experiments and little or no production impact. And now, how do you think? How much should you run chaos engineering experiments? Give me some numbers. What 5? How often? Okay, once a week. How do you think? Every day? Okay. Can you repeat, please? Okay. So actually there are different schools of thought, and your all answers might be right. But it is recommended to do it at least once per quarter, especially if your system is outperforming your service level objectives and exceeding goals set against service level agreements. And Gremlin prepared a great report, which is based on how often teams run their chaos engineering and availability of their systems. And actually, teams that never performed an attack has slightly lower availability than teams that perform it even ad hoc, which is amazing. And right now, with all that knowledge, you want to start your chaos engineering experiments. But where to start? So there are 3 main areas which you can dig in to figure out the smartest way to do it. So first one is look at your outage history. You can find some patterns that often causing failures, and for each one, you can ask yourself, could this be understood, hence prevented, with failure injection? And verify those hypotheses with mini chaos engineering experiment and check your assumptions. Then you can tackle the most common scenarios according to the most breadth radius. Then figure out your critical dependencies. And identifying dependencies and documenting them is called dependency mapping, and it's usually done for huge databases. But you can also prepare a single graph. And we divide those by critical and non-critical. With the criticals, we are sure that our system will completely fail without them, And with non-critical, at least we believe that there should be no impact on production, but it is how it is. And you can start by enumerating your API, finding the most critical one, but you can take more radical approach. Turn each machine one by one and see what happens. Become a chaos monkey here. And probably you won't be able to do it on production because of some security measures due to brute force attacks, but do it on the test environment. Be patient. It's journey that matters the most. And look out for the overconfidence effect, because the bias of it is pretty tricky and dangerous, especially for teams who are working in one technology for a long time or spend a lot of time fixing bugs. Because someone from your team may say, you are safe, it hasn't failed in 5 years? But then in the least expected moment, the failure will come and say, hold my beer, I will do a disaster here. So right now you are ready to start your test on production, right? I just want to give you some tips how to not fall in the most common traps that people tend to fall in when they do chaos engineering. Trap number 1. The success of chaos engineering is measurable by the quantity of vulnerabilities it reveals. And you may find yourself in the situation where leadership is pushing counting vulnerabilities as some kind of metric that you must achieve. And in this situation, you risk making statistics error, which could lead to incorrect conclusions and believing that the system is working different than in reality. What we should focus on, we should focus more on what we learned, what we are good at, because by that, if we understand how things go right, we'll easier do conclusions how things could go wrong. Trap number 2. Only selected members of the service teams need to be engaged in the experiment and preparation tasks. And this is reasonable. This is time-saving if you choose 3 out of 8 engineers in your team to plan and perform chaos engineering. But let me give you an example of Apollo 1 launch experiment. So the launch practice for Apollo 1 was the first one with astronauts on board, which was scheduled for February of 1967. And sadly, the mission never took place. During the practice in January, a fire in the command module killed all 3 crew members. But why are we talking about it here? Since the rocket was unfueled, test was believed to be safe, and there was people didn't take any emergency precautions. So no fire, rescue, nor medical team were present or alerts during the tests. And now, if you do that with your product, with your service team, you may miss some crucial things which will cause a huge fire in production in the future. Trap number 3. The primary focus of chaos engineering is on performing the experiment. So all phases are equally important, so before, during, and after the experiment. Even during the plan phase, you may find some things like some vulnerabilities, even without running the experiment. And after phase is also important because you have some follow-up task that you need to perform. And the last step. There's a fixed formula for implementing chaos engineering. So when dealing with chaos engineering, there are useful scientific guidelines that can help you do that. My hope only here is that you will not look for one universal solution for chaos experiment which will work in every situation, because it will not. Just focus on the approach, on what you learn, what you are good at. And actually, right now, you may inspired with all that knowledge. You may want to do it in your company. And probably first your leadership must approve and not to throw you out of the window. So there are 3 main benefits. Apart from your development and learning path and your growth, that you can show them. It's about resiliency, reputation, and money. And in the perfect world, on-calls should not exist. And none of you would like to be called like at 3 a.m. with the message that system is not working, and then hop on the meeting with the angry client, explaining why it is not working, how to fix it, and when it will be fixed. You would prefer to read a message in the morning that system failed, but it managed to heal itself, so you don't have to worry. And at the end of 2021, there was a huge AWS outage, and many of AWS services stopped working. The extreme example there for me was that there were some like robot vacuum cleaners from Roomba company, and they couldn't clean your house. So, were you affected by that outage or any others? Yeah. Okay. So that's not good to hear. And with those outages, probably your reputation might be damaged. So if it happens like once or twice, customers will probably tolerate it. But when it happens constantly, they may resign from using your services and give you a bad review. And nowadays, people can be pretty cruel and write some nasty things there. So readers may resign from using your companies. And when you use your clients, you also lose money. But here, I wanted to mention how much you lose when your system fails. So how much 1 hour of downtime costs. And it varies probably on the industry, but it's from $50,000 to even over $5 million per hour. It's per hour, please remember. And there were actually like 2 huge downtimes. One was for Apple in 2015, and during the 5 hour of downtime, they lost $25 million. Now, how do you think? How much did Delta Airline lost during 5 hours of downtime a year later in August? How do you think? 100 millions, right? 70 millions. Okay, so actually, it was $150 million. So $30 million per hour. But in the end, please remember, breaking things is not the end goal. Identifying vulnerabilities and knowing your system is the goal. Chaos engineering is not there to make you look bad or demonstrate how broken your system is or to pile more work at you. No, it's rather a friend who will give your customers a better experience and improve relationship with the service owning teams. So, choose your pill and follow. Thank you so much. I here gather the resources. There is a great page like on GitHub, awesome chaos engineering. There's a lot of stuff there. So please read at least one article and thank you.